This is the question of JEE Advanced 2021. In this question, we are given 10 values of theta, which are the positive valued angles in radians, such that their sum is 2 pi. Then we are defined a complex number z1 equals iota theta 1, zk equals zk equals zk minus 1 e to the power iota theta k. So k is from 2 to 10 iota. Consider the statements P and Q given below. P and Q. Let's move to this question. We can easily see that let this be a circle of radius 1. Then suppose this is theta 1, theta 2, theta 3, theta 4, theta 5, theta 6, theta 7, theta 8, theta 9, and this is theta 10. So we could see that z1 equals e to the power iota theta 1. That means this is z1. And what z2? Z2 equals to z1 from this relation, e to the power iota theta 1, which is nothing but theta plus theta. This is z2. Similarly, z3, z4, z5, z6, z7, z8, z9, this will z10. So this is a circle of unit radius, and let's move to the statement P. P is given as z1 minus z2 minus z1 plus z3 minus z2 plus up to so on z10 minus z9 plus z1 minus z10. We have to prove or disprove that it's less than equals to 2 pi. First, see what is z2 minus z1. z2 minus z1 is this length. Similarly, z3 minus z2 is this length. All the chords are length of all the chords are summed up. So if we add up all the lengths, then we would get less than 2 pi, because this length is always less than the length of this arc. This length is always less than the length of this arc. So you would sum up, we'll get a number which is less than 2 pi. a number which is less than 2 pi. And when this will be equal to 2 pi if the limit k tends to infinity, like z k minus zk minus 1 sigma k equals to 2 to n, limit n tends to infinity equals to 2 pi. This is an important result. Now for statement Q, we are given z2 square minus z1 square, z3 square minus z2 square, z10 square minus z9 square, z1 square minus z10 square in modulus. So z2 square minus z1 square plus z3 square minus z2 square plus so on, z10 square minus z9 square plus z1 square minus z10 square is less than equals to 4 pi. We have to prove or disprove this result. Again, we would do that. We would use this result to prove this because the maximum value of the left hand side of statement P is equals to 2 pi. So can you prove that the maximum value of this term is equals to 4 pi? Then we could say that the minimum, no, not minimum, that these value is less than equals to 2 pi. So our aim is to prove that the maximum value of these terms in modulus, that's mean this length, sum of these lengths is nothing but equals to 4 pi. You use this result. Let's move further. Statement Q can be written as summation k from 2 to n, let it be p max, statement p max zk minus zk minus 1 square square, and limit n tends to infinity. P max statement can be written as limit tends to infinity is k 2 and zk minus zk minus 1 into zk plus zk minus 1 from the property of modulus. We could write it as zk minus 1 into zk plus zk minus 1, and what is this, zk plus zk plus 1. This is a kind of complex number, can be understood with the help of vectors. So if we see that if n tends to infinity, then theta k tends to 0. So there is no difference between the vectors z1 and z10 or z1 and z2 or zk and zk minus 1. Both will be nearly equal. So zk plus zk minus 1 can be written approximately as 2zk, and its magnitude will be 2 because magnitude of zk is 1. So take out 2 and then we would get limit n tends to infinity summation k2 to n zk minus 1, and this is nothing but 2 pi. So 4 pi, so the p max statement accounts for the maximum value 4 pi. So the p statement is less than or equals to 4 pi. So the option, I think C would be true. Option C would be true. And I rate this question as a moderate, from easy to moderate type question. Not a tough one. Easy to moderate.